So today we are going to see how can we simplify a summation like this. If we expand this summation, we will get r plus r squared times 2 plus r cube times 3 and so on. So this summation actually often comes in physics problems and some probability problems and some calculus problems as well. Um, So the way we will start is we will start with our infinite geometric series formula. So this is well known. So when we have a summation like 1 plus r squared and every term is r times the previous term. So this can be simplified as 1 over 1 minus r, where r is strictly between -1 and 1, not inclusive. So the way we do it is very simple. We differentiate this side with respect to r and this side with respect to r. When we do that, then we will get this will differentiate to 0, this will differentiate to 1, this will differentiate to 2 times r, and so on. And if we differentiate this guy with respect to r, we will get -1 times 1 minus r to the power of -2 times the differential of minus r, which is -1, and we will end up with the 1 over 1 minus r squared. Now how is this different from this? That we have every term, we have to multiply every term here by r to get a summation like this. Okay, so if we do that, then we multiply this side by r and this side by r, and we end up with our answer of this summation equal to r over 1 minus r squared. Now this summation is an infinite sum. So infinite sums are easy because we have a simpler formula. What if we have a finite sum? We have a finite sum like this. So then what we do is we again start with our geometric series, finite geometric series formula, which is also very well known, which is that if you have 1 plus r squared up to r to the power of n, this can be written as 1 minus r to the power of n plus 1 divided by 1 minus r. The procedure is exactly the same. We differentiate and we differentiate term by term here, and we differentiate this here. So this differentiation, it looks a little bit long, but it's a simple application of the quotient rule, that we square the denominator, then we denominator times the differential of numerator, subtract numerator times the differential of denominator, and if you simplify it, you will end up with something like this. And the difference between here and here is again only a factor of r, which if we multiply, then we will get this answer. Now note that if we have limit of n tends to infinity here, then this guy goes away and this guy goes away, and we are left with just 1 over 1 minus r squared, which was our answer, our intermediate answer right here. Okay, so this is how you can simplify a summation like this. If it is an infinite sum, it's easier, it's just r over 1 minus r squared, and if it's a finite sum, it's still easy, little bit more work, and you end up with a solution like this. Thank you for watching, hope you liked it.